Yes, from expanding or condensing. From condensing, very good. Let's look at another one. Would you like to pick or you want me to pick? Okay. Okay, so let's look at 67. Same page. 1/3 bracket 2 natural log x plus 5 minus natural log x minus natural log x squared minus 4, close the parenthesis and close the bracket. So where is the starting point? Of course, not outside, right? We have to look inside. Can I do anything to this? The answer is no. Can I do anything to this? The answer is no. Can I do anything to this? I have to. There is a number in front of it. Where does it come from? From the power. So I have to rewrite the whole thing. 1/3 natural log of x plus 5 squared minus natural log x minus natural log x squared minus 4. Again, leave the number outside waiting. What would you replace the inside by? Careful. Notice that 2 logs have negative in front and 1 log has positive in front. So it will be natural log, and it has to have a fraction line. And the top, squared. At the bottom, perfect. Now the final step, I have to get rid of 1/3 in front. Root, exactly, the cube root. So natural log of the cube root of x plus 5 squared over x and x squared minus 4. And no one can simplify this in any way. Do we feel better about this? Do we need more examples with expanding and condensing? We're going to use them in equations in a minute. Any questions?
So you said we can't simplify that, but say on the test, you want us to attempt and show that we can't, or just leave it?
No, just leave it as is. Very good. Exponential and log equations. We did solve one exponential equation. It was last time, and if I remember correctly, it was 2 raised to x plus 1 equals 4. I would like to do it again. And then we'll choose other problems, of course. So I'm looking at these two, and I see, and I can say this with confidence, that both sides can be presented with the same base. So the left-hand side is 2 raised to x plus 1. It's a prime number. The right-hand side can be presented as 2 squared, base a prime number squared. So at this point in time, please do not try to simplify. We're not simplifying the bases. We are thinking, and we're saying this. If 2 numbers are equal, because that's what this says, and they have the same base, what has to happen to their exponents? And then we conclude, yes, there is no other way, but x plus 1 must equal 2. I subtract 1, and I get x equals 1. There is absolutely no other way. And this was our first exponential equation. This is kind of a basic one. So let's look at other types. Like problem 19 on page 514. 8 raised to x plus 3, everything equals 16 raised to x minus 1. Like always, I'm asking myself what type of equation is this? And I will have to say that since the variable is at the exponent and nowhere else, it must be an exponential equation. Good. So my second question that I ask myself is this: can I present this and this, hopefully with the same base, and it should be a prime number? If I can't, I have a different alternative, a different option, but I really hope that both sides can be presented with the same base. What will you replace 8 by with a prime number raised to a power? Agreed. And please, now this time I have to put parentheses and copy x plus 3, because I have to show that I'm raising 8 to power x plus 3. What do I have on the right-hand side now? I'm hoping for the same base. If I can't get the same base, then I have to start from scratch with a different option.
2 to 4.
Do you all agree with 2 to the 4th and absolutely mandatory parentheses and x minus 1? Now I go back to the left and ask myself, how can I simplify this? I want to copy the base, but now what happens to the exponents? There is an exponent that is 3 in here and an exponent outside that is x plus 3. This is a power rule, if you remember. A raised to mth power, everything to the nth power. I copy the base and very good. So now I have to multiply 3 by x plus 3, but I have to distribute. When I multiply 3 by x plus 3, I have to distribute. What do I get?
3x plus 9.
Awesome. I copy the base on the other side. I have to perform the exact same operation because I have 2 to the 4th, everything raised to x minus 1. So I copy the base and multiply the exponents. What do I get? Awesome. So now I'm back to the same situation, to the simple possible exponential equation. Two numbers are equal and they have the same base. What must happen? The exponents must equal to each other. So 3x plus 9 must equal 4x minus 4. I subtract 4x, I subtract 9, divide by -1 or multiply by -1, and I got the solution. Okay, you can say, wait a minute, show me. Or show me how to check. I don't know, maybe this is wrong. So I'll go back to the graphing calculator and I will do this. I will raise 8 to caret in parentheses. I can plug in 13 plus 3, which is 16. And then minus, because it's easier to move the right term to the left-hand side. 16 raised to 13 minus 1, which is 12. When I hit enter, what should the answer be if this is correct? So let me show you what I did, only because I wanted to write everything in one line. I moved this term to the other side, 8 to x plus 3 minus 16 to x minus 1. And when I plug in 13, what should I get as the answer if 13 is the correct solution?
0.
I should get 0. If I don't get 0, something is wrong. The solution is incorrect. What I came up with, that 13, makes no sense. So that's how we check. Any questions? Ryan, you had a question? Is this okay? Everyone? Everyone? Ed, is this okay? Good. So let's look at another problem. Yeah, this caught my eye, 22. So we have e to x plus 4. Oops, I said 4 and I wrote 5. 1 over e to 2x. And after this one, we'll look at, if we have time today, if not on Wednesday, we'll look at more sophisticated exponential equations in which the left-hand side and the right-hand side cannot be presented with the same base. Okay, the left-hand side has to stay. There is nothing I can do to e raised to x plus 4. Is e raised to x plus 4. But I'm hoping that the other side can be presented with the same base. Is there a way of writing 1 over e to 2x as e to a power? That's my hope. What should the power be that such that this expression will represent 1 over e to 2x?
It has to be negative.
Negative 2x. That's it. 1 raised to negative 2x is 1 over e raised to 2x. So now I'm back to the simple case, and I can say two numbers are equal and they have the same base. What must happen? Only one thing can happen, which means what?
So the exponent is equal to each other.
That's it. So I have negative 3x equals 4 or x equals negative 4/3. Again, if you have any doubts about this, you can always go back and put in the graphing calculator and punch in negative 4/3. We can do that. Here it is. So we have e. Here it is e right here with the natural log. Second natural log, that's your e. And the power is negative 4/3 parentheses, negative 4 divided by 3, and plus 4, close the parentheses. Of course, I'm going to do the same trick, little trick, minus. I'm going to put 1 over in parentheses, e. You know me, I put parentheses and I come across anything. So 2, and then parenthesis again, because I'm multiplying by negative 4 divided by 3. I didn't have to do that. I could have performed some multiplication here. I didn't have to do the whole thing. But anyway, so I put 1 over e raised to 2 times negative 4/3. And when I hit enter, if the correct answer is negative 4/3, what should I get? Right, if I don't get 0, I'll go back to the drawing board from scratch and say, oops, negative 4/3 is wrong. Very good. Okay, so now let's look at one example. We still have 5 minutes, so let's look at one example that is more sophisticated, more difficult. Let's start with 34. E raised to 1 minus 8x equals 7,957. 7,957. That's problem 34. E2 raised to 1 minus 8x equals 7,957. Yes. Well, I shouldn't even ask myself, can I present E and 7,957 with the same base? The answer is no. So there must be a way of solving this equation for x. It's still an exponential equation. The base is e. The exponent, the variable has the exponent. So there must be a way. So let me ask you this. When we solve this equation, the square root of x equals 2, what did we do? It was a radical equation, correct? How did we solve this? What did we do? How do I solve the square root of x equals 2? We're talking about this one for a moment. How do I solve this? That's why I'm begging you again, and I will beg you for the next 5 weeks, please redo all tests with solutions every weekend. Coming into the final exam, you're going to feel very strong about it. Please do that for me. Set aside 2 hours, 3 hours every weekend and redo the test. There are only 5 weeks left. Not even, if you deduct the Thanksgiving holiday. Okay, so how do we solve this? Chapter 1. Yes, why did we square and not cube? Because the square root is power 1/2. Okay, perfect. So what did we do? We really applied what function? The inverse function of the square root of x, right? X squared and the square root of x are inverses of each other. We couldn't have not applied power 3 because x cubed and the square root of x are not inverses of each other. What do you think in this case I'm going to apply to both sides of this equation? And the answer must be the inverse function of e to a power. What is the inverse function that we just discussed today of e to a power? How is it called? It's the one with a base of e. The other one, I should say, with the base of e. How do we call it? Correct. We have to apply natural log to both sides. Exactly how we did it here. Here we apply the function to both sides. Which function? X squared. Here we have to apply a function which is the inverse of e. Why? Here's why. Because only this function allows us to do what to this? Only this function has that property. No other function on the planet has it. What will this function allow me to do with this power? By the power rule. Let me write this example from scratch with a log because it's not clear enough, I don't think. So let me just rewrite it. So natural log of e raised to 1 minus 8x will be natural log of 7957. Now I apply the power rule, which brings this quantity in front as a factor, but if I omit to put parentheses around the whole power, I will change the problem. So I have to have 1 minus 8x natural log e equals natural log 7957. Now, half an hour ago, we determined natural log e. How much was it? Natural log e. Yes. Since this is 1, I don't need it. So I have 1 minus 8x equals natural log 7957. I don't want you to get scared about this or of this. This is just a simple number. It happens to have natural log in front of it, but don't worry about it at all. It's just a simple number. So now this becomes a linear equation, and I'm solving for x. And I know I ran out of time. So if you would like to take it from here, you will subtract 1 and then divide by -8. And we will check it next time. I don't want to hold you. Who knows what you need to do. So.